Hello, and welcome to your latest SOLIDWORKS modeling learning assignment. For this assignment, we're going to be using SOLIDWORKS to take a part that's already been made, so you don't have to make it yourself. We're going to take this part that's been made and we're going to convert it into a professional drawing. So with that as an introduction, let's go ahead and get started. Now I've already opened up the part in SOLIDWORKS, so this part will be available to you as a part of your assignment. I got this part off of GrabCAD. GrabCAD.com, their community library, has a lot of very useful creations on here. A lot of very creative individuals who are using these things, just showcasing their talents and sharing their works with the world. So always worth checking out. I've downloaded a few manifolds over the years and just looked at them because I think they make fun projects. But what we'll be doing is you'll be using this file and we're going to be creating a professional drawing of it. So as you can see, this has already been made. You can actually check through all of the parts that make this thing up if you're curious about how you would make something like this. It's kind of like reverse engineering on it in that regard. You can always take a part and say, all right, we're going to start at this top shell. Apparently they cut a hole in it. That was the last thing that they did. And here's the sketch that they used to cut the hole. It was just a circle. And then before that, they extruded this little piece out. Before that, they extruded this piece out. I don't know why they wouldn't have just used a mirror, but whatever. Here they did use a mirror, so this is a mirrored version of the other side. Here's a sketch that didn't get used, or possibly was used, but it looks like they were going to try to use a rotation. Here they filleted the edges to round them a little bit. You have your boss extrusion. Here they just extruded the plate. This is the plate that would mount directly to the cylinders block. Yeah, so it's an interesting thing to just break down an existing drawing. What we're going to be doing is we're going to be going in and doing a brand new drawing from this. So I'll go ahead and hit File, New, go to Drawing, hit OK. Wait for SOLIDWORKS to catch up to me. Once again, I'm going to go find our Doan SOLIDWORKS template, just because it's a much more professional output than just simply using a standard file here. And plus this has everything I want on it. Now since I've already got this open, you can import this view right now. Otherwise you would have to go into the model view, browse, and go find the file. I've already got it, so I'll double click twice on it. I'll click on it here, drag one up, and drag one over. Okay, then I will click OK. Now this is a standard 3 model view. If you wanted to have something like this, you could just click standard 3 view, find a part, and it will automatically load all of these up. Now the way that this part was inserted, this view here, which is technically a front view, that view is the here where you would have the front view, the top view, and the right view. This view is not very helpful. In fact, this doesn't show off hardly anything. I would argue that this view is much more useful. So what I'm going to do is I'm going to go ahead and click on this. You'll notice that you have your properties over here. Over here on these properties, you can actually change which view you want to go up with. So here, right now, it's at the front view, and click on top view. If I change it to top view, because this is the model view, these two projected views are going to change as well. So that's kind of interesting. You can make it a left side view, and then once again these two will change as a result. So you have the ability to change which one of these parts is showing up. Now I'm going to go ahead and show it like this. Yeah, I know that that puts this sideways, but I always like showing the best view in the top in the bottom left corner. That's pretty standard for me. If you were working for a company, they may prefer that you have the front view be the front view, the top view be the top view. But for the purposes of this assignment, because it is a part and a part can be easily rotated, I am not as particular about that. I'm much more particular about the best view being down here. Here you have the most space to implement any kind of dimensions or notes or anything in this space, because you have a whole lot of space that goes around it. Whereas this piece up here doesn't have nearly as much space to implement those same measurements. And you can kind of make the same argument about this piece here. That's part of the reason why I just like this one here to be the best view, is so that you have the most space around it to work with. Now let's look at some of the other features that we have down here. You can mirror it. So here, if I wanted it to be reversed, we could flip it horizontally, flip it vertically. Takes a little bit for it to upload, but you can mirror it. That's kind of an interesting feature if it isn't showing up the way that you want it to show. You do have some import options here. If you had annotations in it, you can import them as well. We also have some display styles down here. So right now this is selected as being hidden lines removed. What that means is that we have all of these cuts and lines in here that are doing things. We don't want to see them. We just want to see the part itself. So this is what you would actually see looking straight on it. But we can go ahead and add those hidden lines in, and you'll notice that the drawing gets a little bit more ugly with that. But we can actually see that these are these lofted pipes that have been created specifically for this drawing. You can also just go ahead and click on wireframe, which assumes that it's like looking at it through an X-ray. There is no outside or inside. Everything, every line, every edge is visible. This is just absolute chaos for this part. For some parts, that would be a little bit more understandable, but for this part, that's not so much. You also have the shaded version. So here, if I shade it, you can tell that these are rounded. You may not be able to tell that otherwise without... Yeah, you may not be able to tell it otherwise. So the shading does a nice job of being able to show the curves of an object, which may not be explicitly obvious. And then lastly, you can have just a straight shaded. This will also take into consideration the material properties, both the shaded with edges and shaded without edges. So if you have a darker part property, it will show up as a darker color, or if it's red, if it's green, it won't just show up as gray, but it will be shaded. So yeah, it's really helpful in that regard. For this drawing, I am just going to leave it as the hidden lines removed, just because it's a little bit more visible. We're going to add a couple drawing pages to this drawing, so we'll add some more stuff to that. Here we can also say use the sheet scale versus use a custom scale. So if this gets brought in and it is just too small, and I want just a little bigger, I can go from 1.8. I can use a user-defined custom scale. So here it could be 1.128, or I could even do like 1 to 6.125. And then you'll notice that it gets a little bigger. It's kind of a weird scale to have, but you have the ability to define that scale independently. The thing that is going to be challenging here is that the scale on the sheet scale is actually provided down here in your title block. That's one of the features of this page. So if you do custom scale it like this, it's not going to reflect this. Usually you have to leave a note that says this is on a scale of this to this. I'm just going to use the sheet scale for now. If you need to change the sheet scale, I believe that is in properties, custom, oh no, it's not in properties. This one is in, I think it's in, I will find that out. I'll put it in the next modeling learning assignment video. Because that's something important to know. And that was something I did not look up before this video. Anyway, so we'll move on from that. So I have this now at the sheet scale. What I'm going to do is I'm going to go ahead and say, all right, I got my standard 3 views, but as I've mentioned, this doesn't really show the curves very well, and it's kind of a difficult understanding what's going on there when there's no lines. It's a very weird looking drawing. So what I'm going to do is just try to bring some clarification. I'm going to go ahead and click on this view. This is called the model view. And I'm going to do what's called a projected view. Both of these are projected views. So what I'm going to do is I'm going to pull it up here at an angle like that, and then hit escape. And when I do that, you'll notice that this is now an isometric view. Now, unlike these two views where I cannot drag and move this side to side because every one of these lines corresponds with something on this drawing, this one, this isometric view, I actually can move. So I'm going to go ahead and move it off. Now, if you click on a projected view, you have the ability to change the view, the projected view itself. So if I change the model view, then all of the projected views will update. Okay, except for the one that I changed because I basically set it as saying I want it to be that. But if you click on the projected views themselves, you can change their appearance. So I'm going to go ahead and set this one to being shaded with edges. And you can kind of see now that this is aesthetically, you can tell that those are rounded. But we really can't get a lot of very good details off of this one. For this page of the drawing, usually the first page, whenever you're doing a professional drawing, you're going to try to give the overview of what the part looks like. This means you're giving general dimensions, you're covering general aspects of it, and then you'll cover more details on that drawing or that part in subsequent pages. Excuse me. That's kind of what we're going to do here. So here I'm going to go to the annotation tab. Now the smart dimension works a lot like the AutoCAD smart dimension. So if you just click on a line, it will give you the dimension for that line. So I'll hover over this line, click on it. Oh, I gotta hit smart dimension, apparently. If I hover over this line, click on it, it'll give me that smart dimension. And here I believe this is in millimeters. Nope, this is in inches. It's because I'm in the IPS scale. I'm also going to give the width of this. And I'll give the width from here to here. So I'll click on that line. And I will click on this line. I'll just drag that down. Okay, you'll notice that these are automatically grayed. Unlike in AutoCAD where we actually had to set these at separate layers in order to get them to appear differently. SOLIDWORKS automatically will color them differently so that they stand out more. Let me just give a quick dimension over here on this box. Width. And and then this box length, which is going to require me to click on front and back. And there we go. So exit out of Smart Dimensions. Now another one of the things that I always like to do, here, fun feature, you can drag this and the dimensions will move with it. One of the things that I like to do in all of my drawings is I like to provide some notes, because you can only really, if anybody was handed this drawing, this is the only information that they would be getting. So under the annotation tab here, I'm going to click on Note. I'm going to go ahead and click and drag a text box. You'll notice it fills up with X's and allows you to write a note. Here I'm going to write exhaust manifold obtained from GrabCAD. Details on subsequent pages. Okay, so I'll just leave it right there. Now, SolidWorks wants me to put down another note. It expects me that since I clicked one, I'll do another one. I'm going to escape. Oh, excuse me. Not drink my Mountain Dew today. So how do we add in another page? Well, you go down here to this button that says Add Sheet. Because we already set up our drawing because we want it to be done in this format, when I import a new sheet, it's going to use the same format. So I don't have to go through the same kinds of issues. Now that I'm in a new sheet, I need another view. So here, rather than doing the standard 3 view, I'm just going to put in a simple model view. We'll double click on this because again that file is still open. Put it down here, and rather than do the projected views, which is what it wants to do immediately, I'm just going to go ahead and escape. I am going to change this to being a top view because that shows off the design a little better. Okay, and now we have a couple of other options that we can use to draw some special types of views. So we have our model views and our projected views. Projected views are tied to the model views. But we also have a couple of other things. First of all, we have an auxiliary view. So here, let's say we're looking at this plate right here. If I wanted to do an auxiliary view, I could actually get it to be flat to this plate by selecting this edge. I believe it's this edge. Well, that wasn't quite it. I missed. Let me try again. I'll click on this plate there. It's not liking that plate. Mostly because there's all of that curviness. Let me try clicking here. Yeah. So anyways, you can project off of an edge that way. Escape. So if I had an edge like this that I wanted to project off of, now this is just going to be a side view if I do an auxiliary view from that. You can, sometimes things show up as just lines when they are more than lines in the actual drawing. So here, this is just a side view. What SolidWorks will do is it will create a plane that is perpendicular to that edge from this view, and it will actually allow you to pull away from that view. So here we're looking at C, that's what C is pointing at, is we're looking in this direction at that edge, and this is what you see. Oh, I want to do this edge here. I think it'll show up as flat. No, it just comes up as the same because it is flat. If you had a line that's at an angle and you needed to take a true dimension of that line, that would be the purpose of using an auxiliary view. Here we don't really have many of those in this drawing, so an auxiliary view is not going to help us very much. But like if you had a rock where that rock was inscribed on one face, but that face was slanted, you would do an auxiliary view so that you could see what was written on that rock according to the way that it looks on the rock, rather than just looking at the standard top view, side view, front view. So here's something that we're going to be using a lot of for this assignment is the section view. What a section view does is it actually cuts through an object. So here you'll notice if I scroll up and down here, this is trying to cut it in half horizontally. I can also go over here and change this to a vertical view. We can also change this to a 45-degree view. And then you can also have it aligned with edges. You'd have to pick an edge and have it aligned. So say I wanted to make a cut that went along this line and then came down. That's where you'd use the excuse me, section view. So here I just want to use a horizontal section view. First of all, I want to get 3 of these. One of which is I want a section view right here. I want a section view right here, which is where all of these intakes go into the manifold. And then I want a section view right here in the center. So I will start with the center view. It's going to say, is this section line acceptable? We can also make a couple of offsets. You can slightly manage how it goes, but ultimately I'm going to hit OK. And I would automatically list it as E because we have already created A, B, and C that I deleted earlier. And this is going to come off as section E to E. And what you'll notice here, I'm going to hit escape. What you'll notice here is that there are a lot of other features that we can add on this now. Now this isn't very pretty. In fact, it's kind of difficult to read because it's just difficult to read. But these are the openings that are going to lead to the manifold. I don't know what those are right there. Might help if we play around with some of the shading. Oh, these are the tubes. Looks like there's a line that's present in the tubes. I'm not really sure why. Whoever made this must have left a line. And then those are the manifolds back there. So what we would do here is we would just provide some simple dimensions. Thank you, SolidWorks, for reminding me I haven't saved. We can just provide some simple dimensions for each of these little cutouts. So here I'll grab this width here. Oh, that's not a flat line. So of course it's not going to tell me that value. So I can click on a point though. It's 2.5 inches wide at its widest spot. And then these are 1.5 inch tall, and there's 3 of them. Okay, so we can get some of those dimensions by using a section view. Another piece of this too is that because we're using the sheet scale, which the sheet scale is down here, still 1 to 8. Someone could come into this drawing and scale up whatever they measure. They could actually measure it physically with a ruler, and then scale it up by 8 to get the actual measurement. So kind of a handy feature. In today's world, with a lot of these drawings being digital, in fact almost all of the drawings being digital, the expectation is that you would hand off this file to somebody and they would be able to go in and dimension it themselves and measure it themselves. SolidWorks has an output file type called eDrawings. And eDrawings are used for just that. It's a really, really light application. People can use it to go in and dimension parts, measure lines, measure point to point. and really kind of extract information out of a SOLIDWORKS drawing. So there's one of our section views. So let's go back to view layout. We're going to do one more section view. This time I am going to do one of these aligned views. And we'll go right down the center of two of these manifolds. So it's not liking how I'm doing this. Let me try that again. Section view, aligned. So we'll start at that point, drag down here. And oh, it's looking for the other edge of my cutting line. Let's try that again. So I'll hitting escape. I'll start at this line. We'll drag this one down, and then for my other cut, I'm going to drag it up like this. Okay, and that's okay to me. So this will now be F. And now when I pull this over, you actually see the two different cuts that I made. One of them going down, one of them at an angle. Now that's actually going to make this thing look like unobstructed because it just went along these tube paths. So we can see that there are no obstructions inside of the tube. The tube, this is kind of a curvy loft that was used to make this part. And then it has the two flat plates on the top and the bottom. This is also labeled section F to F. So here, F to F. And there we go. Now, a broken out section allows you to cut out half of a drawing and look at it, and then keep the rest of the drawing in place. If you have, for a model like this, you could do a broken out view of this piece and then leave the rest intact. It tends to be a little bit more artsy than I typically do. A break view is something you use when you have a really, really long part. Like, let's say you were dealing with a part that was 20 feet long and it was only 1/4 of an inch in diameter. If it's 20 feet long and 1/4 of an inch in diameter, you don't really want to draw all of that. So instead you create a break view, and by inserting a break view, it shortens a drawing, but it still allows the dimension to be right. Crop view allows you to take a view like this and cut part of it down, so you don't have to see the whole thing. I'm not going to use that one here. But we do also have the section of the detail view. So here, a detail view basically allows you to zoom in on a portion. It'll have a different scale from the page scale. So if I zoom in like this, click on a center, next one is the radius. This is going to show kind of the outer bounds of where my drawing is. This is now labeled as G, and then when I go up here, I can put this view, and it's that circular shape that's the cutout from G. But here now it's got a specified scale associated with it. So that's kind of interesting. Let's say I don't want this one. I'm going to go ahead and delete this view. It'll also delete the detail circle. I'll hit yes. On this one, I actually want to provide a detail view of one of these ports right there. Okay, so it's a little bit small for me to kind of dimension well. So I'm going to go ahead and insert a new model view. I'll put it here. And now you'll see here are those 3 output ports. Okay. Now since I put this outside of the page, when I go to print this page, this model piece will actually not show up. So that can be helpful because now I can create a detailed view of this. I don't really want to show this view again. I'll go ahead and put it in the center here, and I'll zoom it out. It'll be labeled as H, and then I can come up here, and now I can actually see the port. And I would label this as being the port on this manifold. One thing's for sure, this is way too small. Scale of 1 to 4, it's only twice as big as the other one. I want to use a custom scale of 1 to 2. So just make it a little bit bigger. I'll go ahead and scoot this descriptor in there. Okay, and then I will write a note over here that's zoomed view of the output port for the manifold, or the. So I'll hit OK. Go into annotation, do another note, and go ahead and, if you click a note too close to a drawing, it'll actually create it into a leader. It's kind of interesting. This is a detail view, the output port of the manifold. Okay, so this is another tool that you can use if you needed to dimension something. Here, I wanted to provide this detail on this page, but I didn't want to have to show this view. If you just put this view out of the page, you can have the detailed views on the inside. All right, so now we got to finish this drawing. I'm going to go back to sheet 1. Change of name of drawing to manifold. Okay. What doesn't want me to select everything? Intake manifold. Okay. And for the description, it's going to be general overview of the intake manifold. Okay, my sheet scale is already there. Sheet number automatically populates. Units are in inches. I could change it if I need to. Here's today's date. Drawn by. We'll go ahead and exit out of this. I'm going to go back to my properties, and in my summary tab, author is CJS. So I'll hit OK. That'll pop in. Now for my second page, I only have to go in and change the name of the drawing and the description again, because everything else is filled out. So for this one, these are going to be detail views of manifold. Don't ask me why my SolidWorks doesn't like updating when I type these things. So my description here is just going to be section and detail views of the manifold. Okay, everything is already else is already filled out. Now I have 2 sheets. I want to print them both, and that will be my hand-in for this assignment. So what I'm going to do is I'm going to go up to File and Print. You published e-drawings right there, if you'll notice. I'm going to set this to Microsoft Print PDF, and I'm going to select all sheets, and then I'll hit OK. And this will be my MLA 4. So follow along with the instructions that I provided in this video and hand in the PDF as I've shown you and created right there. And you got to make sure that you hand in both pages of this PDF. So if you only hand in one, you won't get the full credit. All right, I will see you in the next video.